Today, we're going to talk about the term we introduced in week one of Plastinomics. This term we defined pretty loosely in that week. We said we'd get deeper into it, which we will this week. We'll redefine it here at the beginning, and then we'll talk about some of the insights that we're providing our customers through our data that we're currently collecting, things that we've evolved over the last couple years and turned into predictive insights, and really try to put some more meat to the bone for the term augmented intelligence that we've used several times in the last few weeks. Getting back to our relational slide, so this is the topic that we've picked, that we've revisited each week, that tries to help our customers understand where we're coming from, what type of things we're going to talk about for the week. And as I'm sure you've noticed, each week this picture has changed slightly. So we've added things to this each week to show you how cars have evolved, to show you how we're evolving, and to create that mindset and that concept of, here's the tools Millicron's putting in place to help me run my machines, just like things have been put in place in our cars today or linked to our cars through our phones to help us make the driving experience more beneficial for each of the drivers, and safer for all of us as we get more data to help us make safe choices on the road. So in this picture today, there are two things that we want to draw your attention to. First is the dash panel. Again, we used some of this last week, but you can see some of the changes on here that we're going to talk about today kind of point to some of the things that cars do that have really started to change the way we operate and to change the way we look at these and maintenance them in the last 5 years. So you can see the little tab that says oil change due in 1,488 miles. That no longer is done based off of a 3,000, 6,000, 9,000 mile oil count. It's based off of real data from your car, your starts and your stops. There's a computer in there with running some kind of smart algorithm that says, based upon how this person is operating this vehicle, this is when that maintenance item is due. So this is one of the topics that we're going to talk about, and how we're learning to leverage our data from each individual machine to make this smarter, to provide recommendations that are actually based off of how you as a unique individual are operating and using that machinery. The second piece that we want to draw your attention to is here in contrast with each of these different items that we're starting to see come out and be more prevalent in cars as they have self-driving technologies, or as they add new technology packages to these cars. And really, what these technology packages do is especially when you start talking about self-driving cars, is they have to take in all of these additional items outside of just the driver and outside of what's going on in the car, and look at what are other cars going, how fast are they going, how close am I to them, what are the lines on the road look like, am I positioned appropriately in those so that I'm not going to be interfering with any driver, what other unique things may be coming up that I need to look at, and then even taking that to our cell phones, that even if you don't have these self-driving cars with all these technologies in them, your cell phone today is able to digest so much information from all of the different people connected. And you can see we've got the dash panel view there that shows you two routes that are highlighted to get to the same destination. You may be used to taking that red route because you know that that's the least trafficked route, there's the least amount of stoplights, and it's going to get you there the quickest. But when you put that in your map today, the map will pick up and know, based upon other users and other feedback, that there is in fact a wreck on that normal traffic route that you're taking. So the one that has all the stoplights is probably going to be the fastest today. So these topics are what we ask you to keep in mind as we go through today's presentation, and we talk through Plastinomics, and we talk through these insights and the intelligence that we're trying to provide to our customers. So to revisit the term Plastinomics again is all about understanding the economics of molding, and even deeper than that, understanding what each individual customer is trying to do with today's environment, and making cost effective decisions, augmenting our customers' intelligence to give them the right insights they need to make intelligent decisions for their operations, when to change parts, when they may need to look at the process because we see a lot of variation in the process where we maybe shouldn't. We're looking at all these things to provide intelligent insights and to really turn our users into smart users and help them understand what it is that the machines need or that their maintenance department needs to operate the most effectively or efficiently. So some of the things we're going to go through today, if you see down at the bottom, we have a timeline that shows you the applications that we've developed, and we'll go through each of those and get a little bit more into the details. We've talked about those at a high level, but we're going to get somewhat into the details of those, some of the use cases where we've detected these things for our partners, and then we're going to turn that into how we have shifted the platform to this Plastinomics view and shifted that insight into something that looks more towards the customer's top and bottom line, more towards their sustainability goals, and really helps us to drive meaningful recommendations to the customer rather than just, hey, it's time to change this component. So before we get into the applications, what we wanted to do was take a little bit of time to discuss how we're looking at these things and what we're doing to leverage a global fleet and push meaningful things to each individual machine. So with our system, we started, as we stated in each week, we started a few years ago, really trying to understand where we can help our customers the most. And today, what that's turned into are customers that are actually using our data to help manage their business and create a culture of actionable insights based upon machine data. So we have on the slide here where customers review OEE and trends, and that is very true. But this has even turned into certain things today where customers will take these actionable insights, they will generate real live work orders based off machine data, and they will follow up on these items because they know that our data has proven real insights will be found, real things, real benefit will be had by that customer when they perform these items. How have we done that? Now that's the challenging part and what we're going to get to. So here in the first part of this, we started to look at this and said, let's first start by detecting when we can see wear and tear of these components. What that quickly changed into is we need to get to the point where we can give the customer a health score. We want the customer to be able to understand when they're at 100% health, when they're at 80% health, when they're at 50% health, and let them justify when it makes sense to change that. What that's even turned into since then, what we're on today, when we start talking about Plastinomics, is most customers have so many things going on, so many different sensors, so much information coming from all these different places. It's really, really difficult to balance, even with that health score, when these items need replaced. So, what this system has morphed to, and what Plastinomics means, is now we're taking a look at the customer's energy. We're taking a look at the customer's other components, and we're saying, based on those, here's the cost of what it's going to save you, or I'm sorry, here's the savings, potential savings that you'd have, and compare that to the cost of the maintenance or the cost of the wear and tear, and really allow customers to make an intelligent decision of when to perform those actionable insights. I mentioned a little bit about the hardware as well. So we talked week one, and we expanded upon that a little bit in weeks 2 and 3 about our global fleet and how we're leveraging it to perform and learn and develop analytics. Now I want to talk to you a little bit about how we're passing that back into the machines. So on each machine, we have unique devices that allow us to do edge computing. What you see is two examples of those here in that top left-hand bubble in the Symphony and the Amphion, which actually have a lot of capability, onboard storage, and a lot of capability, again, to do edge computing, which means that we're not continually sending millions and millions of data points into our cloud interface. We are constantly learning and then passing back down to those devices ways to mathematically transform that information and make it into something more meaningful, to where we're cutting those in half, or in even some instances we're cutting that down to 1 or 2 data points, where we're able to perform all of these analytics on the machines and then pass that information, only the information you need, into an actionable dashboard. From there, these devices, also having this connected fleet, allow us to push back down to the ones where we're not doing the studies these same type of analytics. So if we, for instance, learn of a failure pattern in a motor, in a unique motor that says a front bearing is going out, it's very critical that we're able to study that, put that on a machine where we're seeing this pattern. And then from there, once we've got something that we know is applicable and will work for the rest of the machine base, be able to quickly pass that down to these other devices without affecting the customer and what they're wanting to do with it and their data pool and their visualization of OEE. But putting it in an effective format, such that it's easy to update all of these and provide the newest morphing analytics as they evolve, as we learn more from that fleet. What we're also showing you here on the right side is an actionable dashboard that we also update as we receive these items to tell our customers what the real-time learnings are from the machine. So do you have a certain component that's failing? Do you need to look at a certain portion of the machine? In the future, we'll talk about some of the things that we're going to recommend as far as training. We talked about the diagnostics. We're working on ways, and we have ways in place of flagging customers in a quick, easy to read format that allows them to take these actionable insights as well.
Eddie, you have a question here. Can you amplify what Amphibian and Symphony are and what they do?
Yes, so the boxes themselves, they have a couple different purposes on the machine. So one, they're there to collect data at high speed, high frequency from the machines or other auxiliary components around the equipment. And they also are there to pass mathematical algorithms back down to the machines and run real-time analytics on that data. So there are two devices that we have with our partner EI3. So we've worked with them to tailor these devices to our unique applications, but they real time read that data. They store it. They have a lot of functionality to store it, even in the event of a loss of a connection. They help us process it. They help us put it into our cloud applications, and they also can analyze it and provide meaningful insight back to the cloud interface. The pump sensor, the Amphion itself, is something that does a lot of analysis. When we talk about, you think about frequency analysis and vibration analysis, and I'll get a little bit more into that here in a few slides to talk about what we do with the pump sensor. But it also has the ability to handle millions of data points every few minutes to do this real-time analysis, and then analyze it, provide a real-time FFT analysis, and then push that either back up to the cloud or analyze it directly on the pump and only push the insights back to our cloud interface.
Yeah, okay. What I was trying to do is distinguish the function of Amphion from that of Symphony, since there are two different devices. What does one do versus what the other does?
Yes, Amphion is there to collect and aggregate data on a work cell. The Symphony is specifically a device utilized to analyze the pump itself and provide actionable insights into our pumps on our machines. This application is being pushed to a few of our beta customers, but it's one that we wanted to get out there to our larger customer base as a whole. But one of the ways that we're taking this actionable insight, and if you think back to our relational topic with the car, where we said it's recommending you change your oil based upon machine data, we're taking that same thought and that same mindset, and we are moving that to the machine. So when we look at these items that we'll see on the next page, and it's important to do these things to make sure your machine's running optimally, we want to make sure that you're being given the right maintenance items at the right time, so you're not under or over maintaining your equipment. We want to be able to do this not just for the machines, but the molds that are running in them, the auxiliary components that are also connected and providing just as much of a value to creating a good part. We want to make sure your whole work cell is running as effectively as possible. So this application really leverages the learnings that we've had over the last 2 years of taking this deep dive with our customers. We've seen in different areas where customers have teams dedicated to this. They've got a whole parts stocking crib that says, here's all the maintenance items we need to do just about anything on these presses, all the way down to, well, we do it when we have to, because it's very costly to keep the people in place to do this when we could spend the money on additional components to keep the machines running or additional people. It's just a very costly item, and unfortunately it has to happen to keep the machine running optimally. So Millicron, in an effort to help with the cost of doing this, with the staff expenditures that we know you have to keep in place to keep all of these work cells and charts, and every time a machine goes down, here's the 10 things that need done. Here's the parts that need to do it. We wanted to really encompass all of that in one application and help you, the customer, start to understand when these things need done based upon the actual runtime of those devices. So if I have 10 things that are due every million cycles on the machine, you want to make sure that you're not going to run over. So if there are things that are sitting at 999,000 cycles, or things that are way under based upon when you would normally do them, we want to make sure that that long, complicated list gets looked at effectively so that you are doing them at the appropriate times. You're not going out of your way to take machines down when they might not need to be. And on the other side, you're not under maintaining them and risking a potential catastrophic failure because you forgot to lube something. Eventually, as we start to morph this system, and we're going to talk about the predictive side here on the next slide, as we look at the predictive side, we're also leveraging that same capability so that some of these aren't based off of time at all. Some of the things that you're going to be recommended maintenance wise will be based off of real time analytics. And in the next 2 years, we have a goal to make sure everything on this list is based off of real time analytics. Now, we may have to put new things on the machine. This may be things that have to be designed into the machine, but in some form or fashion, the machine needs to tell our customers what needs maintained, and it needs to be based on their usage. It can't be based off of customer XYZ's usage. It needs to be based off of what am I doing with the machine? How do I operate it? What parts am I running? And then from there, do I operate a particular mold between 4 or 5 different presses? I need to understand how many cycles it ran between each, how fast it was being run, the pressures that were going into it, because that's also going to affect when I need to look at my molds. So we're taking this thought process, attempting to digitize it, and working with our customer base to make it a meaningful product that provides real time augmented intelligence as to when you need to perform certain maintenance items with your work cells. So now jumping into the predictive side. So this is where we actually take these analytics, we study real-time machine data. In some instances, we do add sensors, and we take these items and analyze real time, whether that's on the machine or in the cloud, and provide insights like you see on the dashboard here on the bottom left-handed side. So in late 2018, early 2019, we started with pumps, heater bands, and screws. And when we go through these next few slides, I'm going to talk about why we went into those specific items. I think everybody can guess at a few of these just because of their importance to the machines. But we really picked these items due to their importance, and one due to the learnings that we knew would be had from it. Jumping straight in, the first one that we picked was heater bands. This is something we thought at the time was not really game changing for our customers. It's something that we knew we had plenty of data around. We could study these. We had enough machines connected. And this is something that would get our feet wet into the predictive world. And what we were quickly able to see is that we were actually able to see when heater bands were failing and not just failed. You can see with our 3 examples here that the first one, we had a failure detected on the 21st of March. We had it confirmed by the customer on the 25th, and we were actually able to see that a month in advance. Skipping down to number 3, you can see that same thing. And the reason that we say we can see these way in advance is because we'd connect a machine, we'd do a study, see if things were failing. So it wasn't like we were sitting on data for 6 months or 5 months. This was us connecting machines, learning, and then passing actionable insights to the customer. But on plot 3, getting back to it here, you can see on April 5th, we told the customer, you have an issue. They confirmed it 6 days later. And we could have seen 4 months in advance that they were having an issue with this heater band. So what we did with our customers was provide this health score, provide this meaningful insight to them, and that resulted in a lot of changes. The component is something that didn't necessarily affect the production. It was something that wasn't always causing our partners to have bad quality. There were certain instances, but for the most part, it was something where the machine could run. In a few slides, I'm going to get to why we've morphed to the Plastinomics side, and I'm going to talk very deeply on why it's important for customers to change heater bands and things we've learned through these data studies outside of just saying, hey, I can tell you when it's going bad. The second component we're going to discuss is the Symphony, or the pump sensor that we use to analyze and detect real-time changes in state of the pump. So the Symphony, what you're looking at here on the left side, is the first version of our Symphony sensor. So this sensor was designed to do real-time frequency vibration studies of the pumps. So what makes this unique is that we've designed this sensor with our partner EI3 to cover a large frequency range, which most sensors off the shelf do not do. The sensor bolts on real time to the machine, and it works with the red box, and it works with the machine to real time look at data to pair up and make a study of a machine and a mold combination. So what we've learned is that certain failures do provide a unique pattern to something that we can pass from machine to machine, but most customers do not operate machines the same way. Even with from machine to machine running the same mold, it could be the same similar design. Maybe a customer has a different set of set points that affects what you see on this sensor with any vibration sensor. So it's very critical that this sensor can be on the machine real time, learn when the machine changes states. It's not something you want to have to constantly run a normal cycle and take the machine down to do these tests. You want it to run real time, because if a problem occurs and something happens with this pump, it could grenade into the system. It could cause extended downtime. It could cause you to have to clean your oil, replace valves. It's a very costly issue when this pump fails. So what we've got displayed up here, one of our success cases where we had a customer on July 4th, we could see that the pump was acting normally. The state was something that we've seen through the past 10,000 cycles that we have been analyzing. From the July 4th to the July 10th timeframe, we could see that change of pattern and that change in state in one of the higher frequency ranges that, frankly, some of the sensors on the market do not get to. We saw this change, and we monitored it. We flagged the customer. Over the next couple days, we watched this yet again change states, expanded into a larger frequency spectrum. Um, on July 14th, which we don't even have documented here, this customer actually called us and said they were experiencing cycle loss. They could not move their clamp as fast because of this pump issue. They had put one on order a couple days before this due to the analytics and the things we were passing to them, but they weren't able to get it and replace it till the 18th. So we've actually trained this model, and we could have seen 3 weeks in advance some of these start to occur. So we've taken these learnings and we're passing these same things to the point where we've had customers 3+ weeks in advance detect this same thing. It's allowed them to get pumps real time on order, have them sitting in stock, and when they wanted to change them out and avoid costly downtimes altogether. So this Symphony is a very unique device, but it's a very critical device to us being able to analyze this real time, pass and learn from the machine itself. So pass information back and forth from the machine and make sure that it's keeping up with the unique characteristics of that machine, and then work with our cloud interface to receive updates from other learnings that we've had across the fleet. Okay, the last component we're going to talk about before we jump into what we're doing in 2020 is our feed screw. What we're looking at here is an accelerated failure. This is not typical or indicative of all the things that you'll see out there with screws in the world. But what we wanted to show you is how our algorithm works, and then talk about why we're changing that and why we're morphing that when we start talking about the term Plastinomics. This specific instance, the feed screw, which is a long lead time item, it's a item that can be very expensive, ones that our customers don't want to track. In this particular instance, it was no different. The feed screw, over a 6-month time span, we could see it started to creep with our algorithms that we're running with its performance. So it started to utilize a lot more energy. It started to put off a unique signature as the wear increased. In this particular instance, the screw actually snapped. But what this has proved to us is that this algorithm can see real time changes in that screw. And we see this across every screw we look at. So our analytics tell us, without adding a single sensor to the machine, that performance is changing. Most of the time, it's over a 2 to 3 year period. It's not something that you'll see in 6 months like this one, but it's very critical to understand and know that your algorithm is working and that it's telling you that these states are changing, so that one, you can see it, but two, you can start putting more analytics to it and get into what we're doing in 2020, which is where we've learned from our customers it's not enough to tell them that that screw is degrading and that it needs replaced. Every customer will replace that screw based upon a different formula. Am I losing a number of parts due to quality issues? Do I have an increased energy cost because it's running, I have to run it longer to recover and build the same shot? Is it doing something to my cycle? Has it finally went over the point where my cool time is not the driver for my cycle? It's the screw itself. And customers will balance that equation to know when to order it and when to replace the part. We also learned that everybody does this differently. It's not something that I can put a one size fits all balloon on and customer X is going to order it at the same time as customer Y. They may even have a 10 times difference in the cost of the screw per the machine. So what we've done with this Plastinomics concept, I really want our customers to understand what that name means to us. We've given our customers not only the actionable insight of your screw is wearing, it's here's how much it's costing you to run that screw and here's what it's doing to your cycle, so that our customers know if it's costing me $10,000 a week additionally to run this screw, it makes complete sense for me to order this, sacrifice the downtime, and get to a point where maybe that number is 12,000 to replace it, but get to the point where I can replace it. We're working on changing these concepts, and some of the things that we've started to add are things like fill case analysis, where we're looking at not just the screw itself, but the screw tip assembly. So this is something that takes a brunt of the application in any molding shop, where this component gets probably replaced 3 times more than any screw or barrel or any other item in that injection end. So it's that component where it's hard to determine where you'll start to see quality defects as this component wears. So the repeatability is very critical. It means a lot when you look at quality. Being able to tell real time without an RJG system or something else that this process is repeatable, we've learned is very critical for a large majority of our customer base. So our system will real time collect that high frequency curve, and it will build, without somebody touching it, a operating range of what we'd expect to see for a particular part that's being made, and it will tell you if shots are starting to deviate out of that standard operating range. So with that, we're able to give you that information in a real, easy to read number for repeatability, with some helpful tips. Now, again, you may be changing your process, you may be using different resins. We understand that, but we want to make sure you know that that cycle is becoming less repeatable. And with that, we've actually found that we can morph that score into a tip assembly health. So you're taking not just the repeatability aspect, but you're saying what does this likely mean for the health of this? And we can show you real time, here's what it's doing to your cycle. You can combine that with your scrap data and say this component is pretty cheap. It probably makes sense that during our next downtime or during our next PM shift that we add this to the list. And this again is one of the reasons we're taking that data and converting those standard maintenance items into real insights based off of machine information coming back to us. So the last piece we're going to talk about here is the efficiency report. So I kind of hinted at some of the things that we're getting to as far as evolving the screw tip assembly. I even talked about on the heater band side, I would come back to a specific example of a component you wouldn't think that necessarily is something you need to look at, how that can change when you start looking at the energy and the cycle effect. So we started looking at heater bands and again, providing that insight to customers. We have a few really good partners that even though it wasn't affecting their cycle, they would change these components when we asked. They would send them back. We would analyze it. We would see what it was doing to the cycle. And what we've actually found is that customers that operate with one, even two bad heater bands are spending $25 to $60 more per day in energy to run that same machine. So amplify that with multiple heater bands, amplify that with inefficient screws, with inefficient screw tips, and you start to paint a different picture on what it costs you to mold. One of our particular case studies in our customers, we were actually saving them $90 a day by changing out two separate heater bands to run their same machine and to run that same product. The product was good in both situations. The customer was making a good part. There was no decrease or defect to quality, but the customer changing a mold, they took 10 minutes to change a heater band. They spent the $200 on the heater band and they paid for it in one day. So these are the things that we're looking at when we talk about an efficiency report. We're not just tracking how these components we're not just tracking how these components are looking and how that wear pattern's going, but I want to tell you how much more energy it's costing you to look at this, how it's affecting your cycle. And then when you start to look at these things in correlation, it also starts to show you other insights. You might look at something and say, okay, great. I see on my screen I'm using less extruder energy, less injection energy. But when you look at that in correlation with your heating energy, did you know that that's probably a indicator of a worn screw, and that screw's energy that it's using, the offset and heating energy that it's having to put in place to take up for what it typically uses to shear the plastic, is way outweighing the cost of replacing that component. So these are the insights that we're focused on. And when we say Plastinomics, this is what we're delivering to our customers. So actionable insights based off of real machine data, based off of real cost, so that you can make an economic and smart decision for your operations. Before I wrap up today, I want to one last time revisit this concept of the car. And I hope you understand over the last 4 weeks how we've built up from OnStar for remote support to different things that help you understand the performance of the car, or computers being plugged in, all the way to some of the things we talked about today as far as insights based upon machine data that we're starting to learn from and being able to pass down to our users to more effectively create that experience. We hope this concept has been helpful. It's something that we see is that it's very relational to this entire empowered and Plastinomics concept, and something we're going to drive towards for our customers and to be a better partner.
Eddie, you have a question from Tony. So going forward, best case scenario, you'd recommend that a molder install a Symphony on all pumps and not try to extrapolate data to other pumps.
Yes, we actually have two of our unique customers that are actually applying this sensor across their entire fleet because of the insights we're able to give them, even across one pump. So we're looking at ways and continually looking for ways to reduce the sensors and the technology that we have to put on machines. So far, this is the only sensor we've added to machines to do our analytics, but it is a very inexpensive sensor that we can add in a cost-effective manner to give you real insight to machines and to your operating state. So it's a very unique way to even look at machines that are 20 years old without ever having to touch the control or update the system, and understand, is that pump changing states and potentially when you're at risk for a failure.
Thank you. You have another question. The feed screw wear out is already available for RoboShop machines?
We do have some tests running on RoboShop machines now as well. They're very positive towards getting to the same point. We do have to add a few additional devices to our RoboShop equipment, but it is very possible to also apply these analytics to those machines as well.
Eddie, you also have another question as a follow-up to the RoboShop. When will it be available?
If we have customers that are interested, it's available today. We do have the capability to pull the data points, get the information we need to perform these same analytics. Again, it just takes us assessing it, finding out what we need to add to the machine as far as equipment to access certain pieces of information. But it's available today for our customers for the RoboShop product line. So again, I just want to say thank you to everyone that's joined us over the last 4 weeks. I think it's been very helpful for us to put all this into a webinar series and create this cohesive message that we're attempting to show our customer base and show the rest of the industry what we're doing, how we're attempting to use data, ways we're leveraging it. I hope each week we've built on that, and I hope we've painted that picture. If we have any questions or any other follow up, again, I please reach out, connect with me on LinkedIn, send me emails, ask follow up questions. I'd love to have these conversations to talk through this. But again, I hope you see that we're continually learning, continually trying to take this data and pass that back to our customers. We have a bunch of buzzwords here, but really the whole intent is to safely and effectively give our customers unique knowledge, unique insight into these machines so that they can make the best decision possible for the top and bottom line while keeping their sustainability goals and productivity in mind as well. So thank you very much for joining us. Thank you for your attentiveness, and I'm looking forward to any other future things we put on for the customers.